All right, hello class. So today we are going to be doing law of sines, and let's look at the formula for law of sines. Sine of A divided by A equals sine of B divided by B equals sine of C divided by C. You won't be using all three of these equivalencies. You'll be using maybe sine of B over B equals sine of C over C, or even sine of A over A equals sine of C over C. And as you could tell by the figure on the right, angle C is projected onto this side C. So it's opposite from each other. Same thing with angle B, length B, angle A, length A. And then if we look at the example problems, first of all, leave your calculator in degree mode. And then in here, they used sine of 19 divided by 16 equals sine of 40 over x to solve for x. So we're starting to get into solving for non-right triangles and how to figure out each side length and whatnot. So because of that, we're going to be able to solve for non-right triangles. And if we're given not enough information in the past, we can use the information given to us to solve for side length, or even in this scenario on the second example for angle A. So let's get started. Let's do example A. I'm gonna pause, so if you want, you could do this ahead of me and then check your work against mine. Fine, up to you. I'll leave that up to you. So, what are we missing? Well, I have x, but I don't have the angle for x. How do I find that? Well, we can use the triangle sum theorem to do 180 minus 20 minus 62. And you get 98 degrees. So for this angle, 98 degrees. So do we have everything we need to use these ratios? Answer is yes, we have everything we need. Solve for that. So we do sine of 98 over x equals sine of 62 over 40. And then I'm going to cross multiply. That's why I drew that x. I get x sine of 62 equals 40 sine of 98. Then I'll divide both sides by sine of 62. And then, so some of you might be asking, why didn't I just solve for sine to begin with? Well, then I'm going to get a very ugly decimal point, and I'd rather just plug it all in, all of that, into my calculator. And it's up to you whether you want to do that or not. If you're going to solve for the sines before you cross multiply, you leave it to 3 decimal places like it is in the example to get a more accurate answer. And if I plug it into my calculator, I should get 44.86. No units, I don't have to worry about it. And I'm going to highlight my answer so you guys can see that I'm done. First one's done. Let's do example B. So, do we have everything we need to solve this example? And before I get started, if you want to do it ahead of time, feel free to pause it and do it yourself before you see me do it or see my answer. All right, and we do have everything we need. So we're good to go. We can just get started. I'm going to start with x. Sine of 140 over x equals sine of 21 over 100. Cross multiply. Once again, I get x sine of 21 equals 100 sine of 140. Remember, you can't multiply the 100 with the whatever's inside the sine. Doesn't work that way. Then divide by sine of 21. And then I get x equals 179.36 when I plug this into the calculator. If you did it ahead of time, I'm hoping that you got the same answer as me. Or I could be wrong, but I highly doubt it. Because this is my third time doing this sheet. But I still could be wrong. So feel free to correct me when next time you see me. All right, so before we begin, feel free to pause it. And what are we trying to find in this problem? Example C. It's a little different because we're trying to find an angle measure. So we're gonna have to do sine of x over 125, because it's on the opposite, equals sine of 28 over 150. And then we'll cross multiply again. 150 times sine of x equals 125 sine of 28. Divide both sides by 150, and I'll move it up here. I'll get sine of x equals 125 times sine of 28. Yeah, that 2 looked like a 7, and so does that one. Divided by 150. All right, so you could solve for that before you take, because I hope that you guys know in your head that it's clicking somewhere that it's saying, oh, take the inverse to get x by itself. Yes, and for me, I want to plug in that entire thing into my calculator. For you, if you wanted to, you can solve for that, leave it to 3 decimal places, and then plug it into your calculator to plug in sine of inverse. And I'll show you the button as soon as I'm done writing with it. So if we look on my calculator, not everybody's calculator is going to be the same, but my sine inverse is when I hit second sine, and then I get the inverse sign. And then I'm going to plug it all in. So I put a parenthesis times sine of 28. Another parenthesis to close the numerator, divided by 150. And then I'm closing the inverse sine function. And I get 23.03. Gonna bring out my trusty highlighter, highlight the answer. All right, looks like, so example D is a little different. I don't have these two side lengths, and that's what I need to find. Do I need another angle to find that side length? Answer is yes. So I'm going to use the triangle sum theorem again, subtract 40 and 19 from 180, and I get 121. So I'm going to label this as x and y, and I got to solve for both x and y before I can find the perimeter of triangle DEF. So I'm going to take sine of 40, and then whatever's projected outwards over x equals, now I need a ratio that has both the top and bottom, no more variables, because I can't solve for an equation with more than one variable. So I'm gonna do sine of 19 divided by 16, and then I'm gonna cross multiply. I'm gonna get x sine of 19 equals 16 sine of 40. Divide both sides by sine of 19. And I'm gonna get x is going to equal 31.59 when I plug it into the calculator. But I'm not done yet, and that's why I haven't highlighted again as well. So I'm gonna turn it over to the backside and do the rest of this problem. Now I have to solve for y. Some of you might think of me as a magician because I'm able to have my equation without looking at the problem. That's right, I am a magician. Doing this straight from my memory. I'm kidding. kidding. I have it written down somewhere. So I'm going to cross multiply. So y times sine of 19 equals 16 sine of 121. Then divide both sides by sine of 19. Almost forgot the 19. And I get, yep, you guys are correct, 42.13. Hopefully you guys are doing it with me. I'm watching you. How do I find the perimeter? All I have to do is add up x, y, and 16. So I have 42.13 plus 31.59 plus 16. And that should get me 89.72. And now I am done. Plus the highlighter tells you I've finished. Since I have finished this, let's review what we learned. We've learned how to use these ratios. We know we can't use all three of them at once to solve for any missing length, side lengths, or any of the missing angles. If you have any questions, feel free to ask me next time you see me. Thank you.